I was thinking, those little pieces of radioactivity that are inside you, it's like you were shot with shotgun pellets. And if we could get a big enough magnet, we could suck them all out of you.
But shotgun pellets are lead, they're non-magnetic.
Go for steel shotgun pellets. And gravity is kind of like magnetism, right? So what we need is a bigger gravity magnet than the Earth to suck all the radioactivity out of you. We could use the sun.
Look, y'all, I've got a high tolerance for BS science. Heck, I've made a pastime out of explaining away BS science, but nah, bro. No. Radiation has always been a shaky subject in the Lois and Clark universe. Heck, it's been a shaky subject with Superman in most media. With the 17,000 types of kryptonite and infinite permutations of things kryptonite can do, along with other absurd radiation plot conveniences, there's not a whole lot of consistency. So, I'm going to do a series on radiation. Most of it will focus on the Lois and Clark universe, but I will branch out into other Superman media. The only thing I won't include at all is Smallville, as the rules regarding kryptonite there are radically different. I only have so much sanity, guys. So, now let's change gears to our dirty bomb in a coal mine. After a, quote, particularly dirty bomb is detonated next to Superman, Clark becomes irradiated such that he can't leave his, probably, lead-lined enclosure for the next million years. But in previous episodes, Clark walked directly into a nuclear power plant on the verge of meltdown, and in the second season, in the episode Top Copy, he walked into an irradiated room to restore his powers. Why is it so inconsistent? Well, let's look at what's different between all of these situations. One is an uncontrolled explosion, the other is a controlled factory setting, and the last is a specialized medical treatment. So, in order to figure out why each of these affected Clark so differently, we have to analyze the situations they were based on. This video, I'm going to focus on the explosion. Who's ready to talk about nuclear bombs? There are two main types of nuclear bombs, the atomic bomb and the hydrogen bomb. Atomic bombs work by shooting a, quote, bullet, or other type of projectile at an unstable isotope of uranium or plutonium. This knocks neutrons and other particles loose, and starts a chain reaction that builds energy until the entire thing explodes. An H-bomb is like a bomb within a bomb. The actual hydrogen part of the bomb would be totally clean if it didn't need an atomic bomb to set it off. Because the villains in the episode were German, I'm making the assumption that they used an atomic bomb, as nuclear research in Germany only really reached this point prior to being discontinued. Near the detonation of the bomb, most people and things are totally vaporized due to the sheer amount of energy. Clark is not destroyed by this energy because he's, invulnerable. But since he's so close to the epicenter of the radioactivity, he becomes irradiated. Now, let's talk about what radioactivity actually means. When something is radioactive, it has an excess of energy, something isotopes are particularly susceptible to. Isotopes are atoms with one or more extra neutrons in their nucleus. A radioactive isotope can give off alpha, beta, or gamma particles, as well as neutrons. These particles don't have enough binding energy to keep themselves together, so radioactive decay occurs. While humans don't have to worry about alpha radiation, beta and gamma radiation pose a threat to physical health. These particles have enough energy to penetrate clothes, skin, or even bone. The impact is enough to damage DNA and causes the body to replicate these damaged cells. The mutated cells cannot sustain their proper function and will cause pain, sickness, and eventually death. Again, Clark doesn't have to worry about these problems, so he just has a whole bunch of cells with a lot of extra energy. Energy that is not properly bound to him, and would give off radiation that's deadly to humans. So why can Clark maintain that radioactivity? Shockingly, the answer is the same as why Clark's trip to the sun actually did rid him of those radioactive particles, despite it being cringe-inducingly wrong. Clark is powered by ultraviolet radiation, meaning his cells have adapted to converting energy from errant particles to calories. This is proven by the fact that he has no need to eat, and that when he absorbs the wrong kind of radiation, kryptonite, he becomes weak. Though Clark is not exactly a plant, the process of photosynthesis is similar. Your average plant converts heat energy to food, but if you set the plant on fire, it can't convert that energy. In Superman's case, the sun is the normal heat, and the fire is kryptonite. But, you may say, how did the sun get rid of the radiation? Well, let's talk about the sun really fast. Our star gives off billions upon billions of high-velocity particles and radiation. So much, in fact, that if not for Earth's magnetic core, no life could exist on our planet. And though the sun's gravity is far larger than that of Earth's, it is in no way capable of the partial spaghettification required to prove Lois's theory. Now, on to Superman. Clark's cells are made to store and convert energy, which is why they contained all the radioactivity without mutating or dying. When Clark flew into the sun, he flew into an incredibly dense field of particles and radiation, all of which contained energy he could convert. These particles annihilated with those already in his cells, destroying and damaging the gamma and beta radiation and replacing it with pure energy that he could suitably convert later, with little to no damage to other humans. Though Lois's explanation was flawed, at least everything worked out in the end. This video is number 1 in the radiation series. In my next video, I'll be talking about the aforementioned radiation therapy in the episode Top Copy. Thanks for watching. If you have any questions or requests for a theory I could tackle, contact me via my Tumblr or leave a comment below.
On the outside, always looking in, will I ever be more than I've always been? 'Cause I'm tapping on the glass, waving through a window.